Hello everyone. I assume that you have had an opportunity to consider this question. However, let's begin addressing this question. The first point here is we have to create graph, then we have to solve this. So there are couple of ways to create a graph. Usually we create a graph by using a map. Okay, so let me show you how in the traditional way. Here we create a map. In map we have a two parameters, key and value. Let's say it's a map. First to new hash map, and again a key and value, like that we create. And key here, let's say consider these nodes are nothing but a numbers, so it should be integer. And value here, if we create relation between nodes, then it's a relation, so it's a neighbors. So neighbors can be multiple or can be a single neighbor, so it should be a list. Okay, so let's say it's array list of integers, because it's again a node. Neighbor is nothing but a node itself. So this is a traditional way, but here is some key point to take it from this question. If you see here, so this map, whatever I have explained here, map key as a integer values, and like key its value as a neighbors, looks like here. If we see, these neighbors are nothing but list. Somewhere it contain only one neighbor, and somewhere it contain multiples. And this is the key, and key is nothing but an integer value that are stored. uh, if I say it's stored as a number from 0 to n, in the range of 0 to n. Okay, so here let's say we are assuming this is our main tree. So here 0 to 5 is the number. So 0, 1, 2, 3, 4, 5 is a key, and its value is the array list. Okay, so we have to use this, but in my question, if I see here, they said vertices or nodes labeled as a number from 0 to n range. So I can take the advantage of basic array. Let's say this is a basic array. Here index is labeled as a 0 to n or 0 to 5. So it is treating as a, or it is acting as a key, and whatever value stored as a array list here, it is a value. So technically I am creating array of array list, but functionally I am using as a map only. Okay, it's a key and value. But here at advantage we do not have to store these keys, because it's a array index, and it's like every array has their indexes in a system, right? So we don't have to manage that. And once we know the index, it is a, like quicker than even a map. Okay, if we know the index, then value should be a quicker. Let's go ahead. Here it says again we have a 2D arrays of ages. Let's say this is the ages 2D array. Okay, it's bidirectional, so I can read out this 0 to 1, like 0 to 1 and 1 to 0. This one also 0 to 2, 0 to 2 and 2 to 0, vice versa. Similarly, you can see here, and it says, the last line says, I have some diagrams here. So it says in between two nodes we have at most one edge. It should not have multiple edges like that. Also, one node can't point out itself. Okay, so these things are given here. And at the end, we have edges, nodes, source, and destination. And we have to return as a Boolean condition. Why Boolean? Just because if you see, source is 0 and destination is 2. So directly from 0 to 2 we can go, and another way is from 0 to 1 and 1 to 2. This is also a way. So we can have multiple choices. That's why we have a boolean values in the return. So as you know, I'm not gonna use this map because we have this 0 to n labeled numbers range, and I can use a different form here that is faster than a map, array of array list. So I'll use that array of array list. So what I can do is I have to use this array list as a integer, or I can do one thing. I can take some methods from list interface. Okay, and this can be array, and here I can say it's a map. Okay, and here I can use array list, and this is an array. That's why here we have to define a size, not array list. Okay, array of array list. That's why I'm defining a size here. Array list is a dynamic in nature, but arrays are fixed. So this is how we can create a array of array list. Okay, so going forward, I'll do one thing. Here we have to create a blank array. If you see here, indexes are predefined. Once you define the length, like 0 to 5, it is predefined. But inside this index, we have to define a blank array list first. Then we can put this indexes, oh sorry, we can put this nodes or vertices later. So I need two for loop. One for just creating array list object, and one for loop to put ages in array list. Here I can replace ages with neighbor. Okay, so neighbors. Okay, so here we have to create, so int I, we know the size, so I equals to 0, I should be less than n, then I plus plus, then nothing else. We have to create this map I, this new array list, and it should be in type as an integer. That's it. Once this is done, what we can do is we can use the ages array. But here, if you look at closely, ages are 2D array. So int ages to age equals to ages. So let's say if it is single array ages, then it can be a normal variable. But if it is a 2D array, then it should be in a array nature. Technically here, if it is a again array, then what I can do is I can use a for loop. Okay, and let's say temp from age, and I can run the conditions here. But the thing is, we can again look into the question. This inside one array, it is fixed. Okay, this is fixed in nature. So what I can do is, instead of a for loop, I can use I can use this 0th and first position directly. Okay, so here we have 0th position and first position, 0th position and first position. So what I can do is I can directly use map age 0th position is related with age first, and it's a reverse condition because it's a bidirectional. So I'll just change 0 to 1 and 1 to 0. 1 is attached to 0. Okay. So now we are done with creating an array. Now we creating a map. Now we have map, so or we can call it as a graph. Graph is looks better here. So I'm just replacing this as a graph. Okay. Now we have to run some methods. So we have two choices. Either is we can run BFS or we can use TFS. So let's check with the BFS, breadth first search. In BFS, what we can do is we have to use a queue. So queue, and it should hold this nodes. So again, integer type. Let's say it's a queue. Okay, new. When we try to implement, it should be a linked list in background. Okay, and very first thing is queue will start from source condition. This is given in question. We have to start searching from source, and till we find the destination, we have to solve this problem. If it is not solved, then at the end we have to return false. Okay. Here the thing is, if you look at the 0 node, it has two neighbors like 1 and 2. But again, 1 have two neighbors 0 and 2. But 0 is already visited. So we have to make a list what is visited and what is not. So boolean should be a best option here. Visited equals to new boolean and its size is n. Visited. Here I'll do one thing. I'll put a source index directly and it's a true. So now the source is already visited. This condition we have. So now everything is sorted. Now we can start searching it. So to search, I'll use a while loop until queue has some data, but we don't have any condition such as, so I have to use this reverse condition until queue is not empty. We have to search it here. Okay, so the very first condition what we should use is queue has some data like source, so we have to pull it back, but again it's integer data, right? So I'm use integer. Let's say it's a current node, or in short it's node queue dot poll. Okay, so what it will do is it will remove source and it will give it to node. Now what we have to do is we have to check its neighbor, and how we store neighbor in it. So it's in form of array list. Okay, so here in comment I'll say neighbors equals to graph is an array. Okay, and if I put it node, it will give me a neighbors list. So in for loop I'll do one thing. It's integer neighbor, pull it one by one node. Okay, so now it is pulling one by one neighbors. We have to check if it is a destination or not. But one thing we missed, that we might get a destination, like source and destination both are same. So till now we did not check if source is equals to destination or not. So this should be our first exit condition. If source equals to destination, then return true. Okay, here again we have to check if neighbor is equals to destination, return true. Else, if it is not true, then we have to check if visited dot neighbor if it is not visited, then we have to what we can do is, first thing is to change this visited neighbor equals to true, then add this queue dot add. What we have to do is, this neighbor we have to check, like what I'm doing is, if 0 is not equals to destination, then check its neighbor. Now let's say if 1 is coming first, so I'll go with the 1 and check if it is not visited, then I'll add to queue and mark it as a visited, so that I can check the neighbors. When I'm trying to check its neighbor, it should get a 2, and 2, if it is destination is 2, then it will mark it as success. Okay, and the last condition should be return false if it is not find anything. Let me try to run it. As expected, I'm getting some errors here. Ages. Okay, add is a method for that symbol. Now it is working fine. See, it is an optimum solution. Thank you for watching.